Hello everyone, this is Ofir Calif speaking, alongside Ariel Rosenfeld. Today we will present to you our 3D maze Java project. So let's begin. We can look at the maze as a search problem, and to solve it we need a searcher. We use for our project a searcher that's called A star, but it can easily be replaced because we use strategy pattern. Let's view this pseudocode. A star works similar to BFS, but it's different from BFS in the way the cost is calculated. In BFS the cost is static, and in A star we use heuristics to calculate the cost in a smarter way, like air distance or Manhattan distance and so on. Let's go through the code. We start running for the first state we're in, and we check if it's the goal state. And if it is, yay, we're done. If it's not, we're getting all of the state successors, and for each successor, we are calculating the cost to get to him. If it doesn't exist in the closed list or in the open priority queue, add them to the open priority queue with calculate the cost and the node that they came from. If it doesn't exist, check who has the better cost and update to the better one. And the loop will continue on until we reach our goal state. Let's demonstrate our project. First, let's start the server. You can see that it loaded its configuration, but we can also change it from the GUI. For now, we will use the XML configuration and press start. Now let's start a client. We can load a maze from a file or generate a new one. For now, let's generate a new one. After we created it, we can save it. Here you can see that we have two screens, one for cross X display and one for cross Y display. This lets the user know all his possible moves. A cool feature we have is that we can zoom in and out on the maze. Let's open another client and generate a new maze. The hint button and the solve button connect to the server and ask him for a solution. So you can see that when I press it, the user connected to the server. Now let's ask for a solution, and you can see that the character is starting to move towards the exit. Every time we ask something from the server, he checks if he have it in his cache. And if he have it, he just return it. And if not, he solve it and insert it into the cache. And this is our solve window. So now let's close everything, and you can see that all threads are closed without an error. Now let's talk about our design for the client. In the client we use architectural pattern that's called MVP, that stands for Model View Presenter. We use this pattern so that our code will be modular, easy to understand, and lets us work in parallel. In this design, the model and the view are independent layers that doesn't know the presenter and each other. Using the observer pattern, the presenter gets events from the model and the view and commands them. As we can see here, the user does something in the UI that raises event in the view. The presenter catches that event and runs the required method in the model. When the model finishes job, he also raises an event, and the presenter catches that event and runs the required method on the view. The model is responsible of all the logic, but it doesn't mean that it's doing all the work. Some methods in the model layer connect to the server to get the required solution. For example, when the model needs to solve the maze, he asks for the server to do it for him. Our model knows what to do, but it doesn't know when to do it. So let's talk about the view. The view layer is rating as an event-driven programming. We have the generic basic window that continuously listens to defined events that may occur at any given time. Upon the occurrence of the event, is inserting it to the event queue, and the main loop extracts him and triggers the event handler. The event handler just knows what happens and when, but he doesn't know what to do. So he raises an event and let all of his observers that something happened, and the presenter takes that from there, as we explained. Now let's talk about our server. For our server, we also use the MVP design pattern. In the presenter package, we have the class that's responsible of the server properties. For this class, we want only one instance, so that everybody who uses her will get the same properties. So we use the singleton pattern. The singleton pattern does not allow to create an instance of this class. That is why our constructor is private. But the class has an instance of itself that makes it the only instance of this class. Notice that we are using synchronize for this getter to make sure there is only one instance, even if we are using multi-threading. Our model here is our server. Among the server data members, there is the server socket that lets the remote client to connect to us, thread pool that opens the thread for each client, that have a limitation of course, the client handler that handles the client. So when the start method is called, the server initializing and waiting for the client to connect. Once a client connected, the client handler is called. The client handler is a protocol for the communication, so the two sides can talk and understand each other. So here you can see that the client sends an array, the array list, that the first cell is the command and the others is the parameters. And the server sends the solution, and the clients return a word done. That's it for now. Thank you for listening. Goodbye.